Good morning and welcome to Leading Technologies in Yacht Navigation. This is a webinar that we're putting on this morning right after the Fort Lauderdale International Boat Show to kind of bring into focus some of the key points and important aspects to technologies on the water right now to help vessels, both large and small, yacht and commercial, navigate safely and improve the experience on the sea. So today we are joined by three panelists. We have Christopher Ballin, he's from Germany. We've got Todd Allen out of Seattle, Washington. We got Matt Zimmerman out of Rhode Island. So we've got a pretty strong presence from coast to coast and across the pond. And I'm Rick Thomas. I'm joining you from Fort Lauderdale, Florida this morning. Really, the introduction to this whole webinar is based on why do we care about navigation, specifically the technology used in navigation. And I think I can safely say it's really how do we improve safety on the sea. Certain aspects come into play. Reducing risk is reducing the human costs. Human costs are sometimes obvious, sometimes subtle. Obviously, injuries and fatalities. It's been happening since we've been on the ocean over the eons, and it will continue to happen. And the best we can do is improve what we do. Going to sea is dangerous. Reducing risk and reducing environmental costs. Well, Exxon Valdez, I think, brought that into sharp focus quite a number of years ago. There's continuing instances of collisions at sea, collisions with things we should probably never collide with. We see oil spilled, we damage our coral reefs and infrastructure. There's a lot of reasons to improve our visibility at the waterline and below the waterline to mitigate those issues. And let's talk about business. We're all in business to make money. You've got a return on investment with your vessels. And if your vessels are causing problems, it's going to be expensive. So you got environmental cleanup costs, you got repairs and loss to the vessel. You got, for yacht owners, the disappointment that all of a sudden you don't have your asset available to you when you want it. And of course, ultimately, if you have a serious injury or fatality, not only is that devastating to families, it's also expensive to deal with as well. So, I think we can say that there are a number of good reasons why we should be looking at and investing in continuing our technologies in navigation and navigation devices. And I've got with me three guys today that I think can really bring a conversation to the table and bring out some of the new technologies and improvements on existing technologies and make this a very interesting morning for everybody. So real quick, I'm going to introduce Todd Allen. Todd is with NAVTOR. They're a company that has been in the business for a while, and I think some of what Todd has to share with you is going to be really interesting. We have Christoph Ballin. He's with SEA.AI, previously known as Oscar Navigation. SEA.AI, or artificial intelligence, is something that alarms or lets people know, the helm know that you got objects on the water ahead of you. And of course, we have Matt Zimmerman with FarSounder. FarSounder's got some really cool 3D forward-looking sonars, and it doesn't take much imagination to understand how important that is in the helm when you're at sea. So, with that said, I'd like Todd to introduce himself, please.
Yeah, hey Rick, thanks for the introduction, and yeah, thanks for everybody for joining tonight, or today, I should say, this morning for me. And yeah, I guess we're covering quite a few time zones. And thank you, Matthew, for organizing all this. So yeah, NAVTOR, I mean, can kind of chime in on exactly what Rick said. We were formed to really try to harness technology to improve safety on board vessels. And we do that by simplifying the tasks for the navigation crew as much as we can. So we just want to make sure that the technology is there as a tool, and it's not a hindrance. It's not something that actually slows people down, but actually improves operations and improves safety. So.
Excellent. Good, quick, brief introduction. Thank you, Todd. Christoph, you're joining us from Germany, and you've had recent changes in your company. I'd love to hear about that, and specifically what SEA.AI really does for us.
Okay, thanks, Rick. So first of all, why don't we, first of all, I'm one of two managing partners at SEA.AI. It's a young company founded 2018. And regarding a question why we changed the name, the company was founded in kind of a grassroots movement in various countries with various organizations. And so every organization was called differently, and the product then was called differently again. And in the course of growing the company, we have streamlined everything and put everything under the same umbrella. So now everything is called SEA.AI. That's the background for the name change. And what we are doing and bringing to the table in terms of making yachting safer is, as you said, Rick, we combine camera technology with artificial intelligence. And due to that combination, we can do a couple of things. On the one hand, we see pretty detailed what's going on around the vessel at day and at night with thermal and RGB cameras. And so we can detect also smaller objects that typically evade conventional surface technologies like radar and AIS. So we're talking small vessels, we're talking fishing buoys, we're talking even swimmers on the water. So we can see small objects and give warnings. And the second thing is, because we combine it with AI, our systems know what they are seeing, so they can provide intelligent alarming to avoid collisions, to provide perimeter surveillance, and it can also present it in a very easy to understand fashion. And so this is what we try to bring to the table to improve situational awareness on boats and ships.
Fantastic. Sounds interesting. Brings to mind an experience I had this summer. I was working with the seakeepers, and we were escorting a bunch of paddle boarders from Bimini across the Gulf Stream to Fort Worth. And these are small vessels, paddle boarders, stand-up boards, crossing the ocean. And we had 3 ocean-going container ships. This is at nighttime. We left Bimini at midnight, of course. So we're in the darkest part of the night, and we're watching these ships navigate through about 120 paddle boarders that were making their way across the ocean. I could imagine your technology would have been very helpful in that application.
Yes, we see them even if they fall in the water.
Yeah. That's awesome. Cool, great stuff. And Matt, I'm somewhat familiar with FarSounder. It's a pretty cool technology. You know, forward-looking sonar is amazing technology. I've got my oldest son was a submariner in the Navy, and he worked in the helm and was using that kind of technology. I guess some of the stuff he did we can't talk about, but you probably can talk about your technologies here.
Yeah, certainly. Thanks, Rick. So I helped form FarSounder over 21 years ago, and our initial motivation was really coming from the environmental point of view. We're based in the Northeast of the US. And for us, we wanted to help develop a technology that could avoid hitting whales, because right whales live where we are, very endangered, and generally don't die until they're hit by a boat. We also had an oil spill local to where we are, small in the world of oil spills, but large by the local standards. And I thought, there must be a way to see rocks and whales. And when we looked around the marketplace, we were really surprised there wasn't a tool to do that. And of course, seeing things underwater is really critical to navigation. In my opinion, the most basic information is what's underwater ahead of the vessel. And you can't see ice, you can't see whales, you can't see shipping containers, you can't see a lot of obstacles with the other tools out there. And so forward-looking sonar really became a great complement to the other technologies, like camera systems, like charts, like radars, and AIS. And so we really like to fit in to the navigation picture by filling in what's underneath the sea surface. Before we get started too much farther, I did want to take a moment to introduce Rick He's the moderator today. Many of you probably know him from his 35-year apprenticeship at Nautical Structures. He recently retired from there and started up as the president of JMS Yachting USA, opening the Florida office for JMS Yachting. As many of you know, JMS Yachting is one of the leading independent yacht management companies, so they now have a Florida office. I've known Rick for years, and he's really known as a collaborator, and he brings people and companies and technologies together. So when we started thinking about this roundtable, he was an obvious choice as someone who can bring together experts from different parts of navigation and facilitate a nice conversation for everybody here who's participating. So thanks for taking on this role, Rick.
Hey, Matt, thanks for the introduction. That was kind of you. And yes, I'm a boater. I've been boating all my life. And while I would love to have some of these technologies we're talking about today, my little boat has very little of that, but I can certainly appreciate the need for it. So with that said, a few thoughts, a few things I want to kind of engage with. First of all, when you see these technologies coming into the helm, there's a lot of information that's rolling in, and that can be a very good thing. At the same time, it could also probably be very distracting. I'd like some opinions on how you can incorporate these technologies and at the same time improve the watch keeping purposes that are ongoing on a vessel that's underway, particularly underway at night or in reduced visibility situations. Who would like to take that?
I could start a little bit, and I'm sure that Christoph and Todd also have pretty good input as well. In my mind, the navigation is really sort of three scenarios. One is the planning. You're going to go somewhere. You want to know, is it safe and how you're going to get there? The second is you're following your route. And you're basically watch keeping. You want to look for things that were not part of the plan so that you can avoid them. And then the third is when you're going into some place that you know is a difficult navigation process, you are doing more than just watch keeping. You're trying to really monitor all of your information in an easy way in a very stressful environment. So that you can get to the place you want to go. For the yachting world, it might be the boss says, I want to go have lunch in that lagoon over there. And maybe the transit lanes are well known, but now you got to figure out how to make your guests happy. Mix that with sun in your eyes or nighttime. We want to be able to use all the tools together in a way that makes that task simple and efficient and easy to use. So I kind of see navigation as those three separate components working together to have a successful cruise.
I couldn't agree more with the summary. I can only add something on the importance of situational awareness and understanding the surroundings of your navigation. Because on the one hand, if we look at accidents and people being affected, of course, we have a lot less of this at sea than we have at land. So if you look at how many people die every year in traffic accidents at land, of course, the number is dramatically higher than on sea. On the other hand, of course, a lot less people are going at sea. And so your individual risk of encountering a dangerous or potentially even tragic situation is a lot higher than on land. There's a Shell Zero Accident report that is often quoted in that context that says that if you're going at sea, it's about 20 times the risk than traveling on land. And if we look at the reasons why these accident happens, no matter whether we look at shipping or whether we look at yachting, number one is collisions, followed by flooding, capsizing. And if we look at the drivers for collision, also no matter whether we look at boating, yachting, shipping, it's always improper lookout, inattention, in the recreational sphere, inexperience, and in the commercial sphere, then followed by communications. So overall, it's a very important safety topic. And it kind of follows the 3 Ds of robotization, the classic rules of where you try to automatize and bring things together. And the 3 Ds are everything that is either dull, dirty, or dangerous. you try to get machine support. And if we talk about lookout, we're not talking about dirty or dangerous, we're talking about dull. And so it's important that we offer crew members intelligent solutions that support them.
So what I hear here is there's a huge human factors piece that comes into this. You know, you have individual roles on board the boat. You've got the helmsman or the captain who's in charge of directing the vessel, but you've got lookouts, you've got watch keepers, you've got the navigation issues. Now you've got 3D imagery, color, really cool radar overlaid with sonar, overlaid with forward-looking infrared cameras. And all of a sudden that helm becomes very busy, very interesting. Could you get myopic? Is this something that you need to be worried about, that people are so focused on looking at their really pretty screens and all the data that's coming at them through the screens that they forget to look through the windscreen?
Definitely.
Oh, sorry.
Go ahead, Todd.
I was just going to say that we, at NAVTOR, we got started basically helping shipping companies transition from paper navigation to digital, using digital charts and digital publications. And there's a lot of advantages, of course, to being able to use digital products. But I think it's important what you're saying, Rick, is that it's kind of like when you're watching sometimes these business channels and they have a ticker symbol for the stocks and they have little breaking news and everything starts popping up on the screen and it's just information overload. So I think it's important. I mean, there's so many advantages to getting information to these ships and yachts at a quick pace, but you have to give it to them in a way that they can digest it. So, and then of course it doesn't replace your brain, your eyes. You got to still look out the window. So
let's hope so.
Yeah, maybe in the future that might not be as necessary, but now we still need to do that. So
yeah, for sure.
We see it a lot as reducing data into information. So we want to trim away data so that the user who's busy doing a lot of things can just focus on the information. Obviously, their eyes out the window are the most basic information, but there's a lot of times where your eyes aren't that great. When you're in dense fog, when you're in heavy rain, when it's at night without a moon. So looking at all the tools together to give you information in a concise way is really important. Of course, you can always dig into the data of one specific sensor or tool as needed, but to be really effective, all these tools need to work together in a way that provides the real information that's needed.
Fascinating. What brings me to another thought, and some areas where I touch on in my professional career in yachting. I'm on the technical committee of the ISS, International Super Yacht Society. So we're looking at all sorts of issues with LSA, LAME, IMO. In the yacht management world that I'm currently working in, we do a lot of compliance audits, and we work frequently with ISM International Safety Management requirements. So follows on that you're talking about some pretty important technologies and some pretty important potential life-saving appliances in a way. Do you fall under SOLAS or IMO or LAME or any of those? And if you don't, should you? Is there a path that this technology needs to walk down into the world of vessel compliance?
Well, I can only talk for FarSounder. Our equipment is really unique. There's no other products that are doing what we're doing. So we're working hard to set the standards of how we should be presenting the information in a simple and easy way to understand. But that being said, we're using components from existing standards. For example, we have a 3D sonar display, which is kind of sexy, showing you the 3D image, not only in front of the vessel, but also your history map of where you've been, all those depths. But we also overlay that information on top of a chart. We happen to use NAVTOR technology for the chart display inside our software, and they're following standards for the display of that chart information. Todd, you can probably talk a lot more about those than I can, though.
Yeah, I was going to say, I mean, we're following strict standards in terms of what's required for an ECDIS, because a big part of our business is actually supplying and updating the official charts for the ECDIS. So, and that kind of also leads to how we develop our own software. Of course, when we display charts, we want it to be following the same rules as it would in the actual ECDIS when we display weather and other things. So, pretty much, like, I guess, now that I think about it, like, everything we have is part of SOLAS or is required on board. So, yeah, it's very important for our part of the picture here. So
Exactly. So inside our software, we're taking components that are regulated in other products, using those same standards. So because we're using the NAVTOR engine, we have the standard S52 display for the chart drawing and colors. And then where appropriate, we continue those approaches and techniques in the other parts of our software to make it as easy to understand as possible. And there's a lot of lessons that we're taking from the sort of the other markets out there, like smartphones and tablets. What are the use cases and the user experiences that we can learn from? Not everything is applicable for what we're doing, but some of those are. And I know, Christoph, you have some great tablet versions of your software. Is there anything that you want to add there?
Yeah, so our products are not regulated in that sense. So we try to, exactly as you say, establish a UI, a user interface that is and user experience that is intuitive and easy to understand. And I believe in the longer term, as we will see more integrated systems, and as we will see, we'll probably come to that later, also more powerful assistance systems, probably even taking over certain functions of the captain, then regulation will become extremely important. And I think it's important that this discussion starts now, and I think it already does, because in a couple of years, we will have some progress there. And what you say is right. So we offer like alarms, not only on MFD or onboard computer, but also on tablet, smartphones, in the future also on a wearable. So wherever you are, you can get an alert.
Okay. Well, to be a little bit of the devil's advocate as well, again, I'm a boater. I have some basic navigational aids that I use, charts that I use. The charts that I use give me, I think, a pretty clear picture of what's in the waters around me, ahead of me. Is that enough? Are we overreaching or trying to make things too information, or don't we have a clear enough picture of what's underneath the ocean surface right now?
I think the charts are a great backdrop for giving you the background information. And in some places, they're pretty accurate from recent surveys, but things change. Some locations, the bathymetry, the seafloor, changes from year to year or season to season. You can think about the river channel or the estuary where the currents actually push sand around, or winter waves bringing sand offshore from the beach, and then spring waves pushing them back onto the beach. But you might be really surprised to know that we're not really doing a good job mapping the seafloor in general. As a quick comparison, as back early as 1997, we've mapped 99% of the surface of Mars at 6-meter resolution.
Wow.
But as of June of this year, only 23.4% of the Earth's seafloor has been mapped. And that percentage is only at 100-meter resolution. And that means 1 point every 100 meters. That's not enough to help you navigate.
Right.
You miss things. Certainly there's places where there's very high resolution surveys, much better than that. But to consider the whole 23.4%, that's only at 100-meter resolution. The US has some of the best charts in the world, and they're really a leader in hydrographic surveys. And as of this year, they finally mapped 52% of US waters.
52%.
Yes. Okay. Some of that is like really deep water, where from the navigation point of view, you don't care too much unless you're a submarine like your son. But even in shallow waters, there's a lot of places that aren't mapped. And especially where yachts are starting to go more and more. For example, Alaska is becoming an increasingly exciting itinerary. And if you look at the charts in Alaska, Captain Cook is literally official data in some places. And those are measured by lowering a rope with a lead down. Those are US charts. And if you go a little farther north along the coast of Alaska, US waters, US charts, they're blank. There's nothing there, which is amazing. So, explorer yachts going to these locations. And a lot of people would probably even consider Alaska not really explorer yachting. It's a known place, part of the US. It's off the beaten trail, but it's not forging new paths. Think about when you're now going Northwest Passage around Greenland. There are new places opening for navigation. In polar areas, there's ice that's moving debris and stuff trapped in the ice. In tropical areas, there are a lot of nice maps that have been made. Starting 1940s, echo sounders were starting to be used for surveys to get good bottom measurements. But they didn't have GPS or DGPS, so the positioning could be off by 500 meters or more.
Wow.
And I'm sure that every captain who's gone through the Caribbean or Fiji or Indonesia has come upon an island that, the shape of the island or the reef or the obstacle and the depths were pretty correct, but totally in the wrong place. So, maps are great backgrounds. Charts are that measurements under the water as great background information. And they play a really, really important role. But they're not correct and things change. So I really think like adding other tools on top help you get through there safely.
Yeah, it sounds like your technologies are doing a really good job of bringing what I'd call real-time information to the helm.
But also camera systems and radar systems and AIS, they all work together.
Well, and that's a good segue into what I was going to ask you guys about. I'm talking to three pretty strong industry professionals here today that each have their own path, each have their own technologies, systems, and businesses. You introduced me as a collaborator, and I would say that's correct. I've made a living and I've made it through this industry for almost 40 years, really collaborating with a lot of different disciplines within the industry to make things work. What's your thoughts about your technologies? There's some proprietary technologies. I'm certain of that. There's multiple other companies such as yours, similar to yours, that are doing similar or different technologies. Is there a philosophy that would bring all of this together into one interface on the helm? Do you want to share information across platforms, or is this something where individual companies are left on their own to do the best they can, and you start lining up 1, 2, 3, 4, 5 different interfaces, in one space to give you that 5 points of information that the helmsman may want or need? Anyone of you guys can jump on that.
Is that it? No, no. Well, I think we partner a lot, actually, and we know that we're basically trying to build platforms where information can be easily visible for the navigation crew or the management of ships as well. So we know we can't compile all this information ourselves. So we partner with weather people. We partner with environmental regulations professionals that can provide us a layer of all the rules. Because environmental regulations is a great example. That's something that changes internationally. It's not too difficult, but when you come down to the individual port of each country, there's so many different rules that change all the time. And these crew are being asked to do so many more things and trying to keep track of all this stuff in different ways. So what we're really trying to do is, I've said it, of course, 1,000 times, it's just, trying to build a platform where they can easily find this information and make their life a little easier. So our real strength is actually building platforms that are simple to use. The technology behind it is actually highly complex. It's kind of like I said this before, it's kind of when I grew up trying to record shows with my VCR. No, some of the people on this call may never had a VCR, but I mean, it was a highly complex thing to do. But then when you look at like an iPad nowadays, it's much more advanced, but it's way easier to use. My mom, who is like 85, was using it. My kids that were toddlers just pick it up and start using it. That's kind of like what we want to do for the bridge.
Yeah, great.
We want to give them something they just use. They don't need to know about how to use it. They just need to get the information that's needed, basically. So
excellent. Well, Matt, leading into this, we were talking, before we started this, and you mentioned that you've got some video showing some of your examples of integration. You got something you want to show us this morning?
Sure. Well, let me just start by sharing a little bit about my personal philosophy about integration. When we have different sensors across the bridge, I think they need to be able to talk to each other and share the information, even if the data lives with each one individually. I love the look of glass bridges, the fully integrated, everything's in one platform. But I'm sure that everyone who's been on one of those bridges has also experienced the stuff isn't happening. I can't get the information from point A to point B for whatever reason. And so my personal philosophy is I like to have a fully integrated solution with the fallback of accessing each sensor individually. And FarSounder sensor, as you know, is a 3D forward-looking sonar. So if I just share my screen for a moment, we produce really fundamentally this type of information. Blue is deep, yellow shallow. Everything in the pie wedge is looking forward. Everything behind it is that depth history of where you've been. And this is nice, but having the integrated picture allows you to understand the context. So that 3D view is just one of the screens of our software. And we're showing right now, integrating that on top of a chart. And like I mentioned previously, we support all the standard chart data sources, but we're using the NAVTOR engine as part of that integration. And you can see here, we're seeing bridge pilings in the sonar. Overlaying it by integrating onto the chart gives a much better understanding of what those things are. Yeah, those are bridge pilings. It also shows AIS and ARPA targets. So when the sonar is picking up tracks from the wakes of the bubbles from their wakes, we see that as the ARPA or AIS tracks correlating with the sonar tracks, it gives the user a lot of valuable confidence in that data. When the sonar matches the chart, you have high confidence in the chart. When the sonar doesn't, then you want to really pay attention to other sensors. And like we have here today, one of them is SEA.AI. We've started working on a proof of concept integration, adding SEA.AI to our software so that targets that they detect would show up on top of our chart display. So this is really an integration of all three of our products together. But this concept is applicable to any specific supplier. It doesn't have to be us three companies. This concept in general, I think, is important. But our software is not replacing the ECTA system. It is a complement side by side, getting the information across and leaving the data in their respective individual sources.
Yeah, I see that. And I'll get it brings up a couple of questions. I don't know if the people listening and watching us today are asking the same questions to themselves, but what I just saw was a map of the seafloor. What kind of depths does this technology go to? And would your data that you're collecting that's heading up to the helm of that bridge be able to go into a database that increases our mapping from 52% to something greater as more and more boats use this technology and potentially upload this information?
Yeah, I'm glad you bring that up. FarSounder is actually part of the IHO's crowdsourced bathymetry working group. And that's a group that's a combination of industry, academia, and hydrographic offices. trying to work out the best ways to use community contributions. And we actually are working with a select group of our customers to collect data when they're going interesting places. They send us the raw data, we compile it, and we contribute that to the IHO's crowdsourced bathymetry database. And that actually gets shared with SEA.AI 2030, which is a global effort that is operating under the auspices of the UN and the IHO to build a map of the ocean. So that, obviously we're trying to match that Mars capability.
Yeah.
And all that information is available for use by anyone. Everything that's contributed to the IHO's crowdsourced database is available for anyone to use for whatever purposes. That could be scientists going into a weather model, or it could be hydrographic offices trying to figure out where they should send their survey vessels for that next survey. And we're doing that, but you can do that with echo sounders and other technologies as well.
Cool.
And in fact, I'm going to be at Rethink's Night Out in 2 weeks, the night before METS, giving a little presentation on SEA.AI 2030. So if anyone's there, please say hello.
I will be there, and I will say hello. Fantastic. Now, leading into this conversation, it's no surprise the four of us got together and had a couple chats. And Todd, I know you had some thoughts, and I think you have also got a short demonstration to show about how you integrate navigation planning with the actual voyage. You want to get into that a little bit with us while we still have some time?
Sure. Yeah. So as I mentioned, we got our start basically helping ships to transition from paper navigation. And a lot of the complaints that when they first started to do this, a lot of the complaints were, well, we used to have this big chart table that we could see a big overview of where we're going. And now we're trying to navigate on this tiny little screen. So we kind of took that to heart and decided to develop what we call a digital chart table. So I can't really show you that exactly in this platform. It would be nicer to be in person and have like a big 55-inch screen, but I can show you what it looks like on my computer. So just give me 1 second. Let me share. So this is what we call our digital chart table. And what it is it's just layers of different types of information. So traditionally ships would have to go into each individual one of these boxes and open it up in a separate platform. But what we've done is integrated all these things that you would need for planning into one place and automate as much as we can. So the information in here is updated every week automatically. And then they could turn on layers as they want to see them. So it starts with the actual chart layer. And then you can turn on things like weather, for instance, which is, of course, a very important thing to know about when you're planning a voyage. And you can, basically add different layers like environmental regulations. And in turn, you can build the passage plan automatically. And what this really is a complement to the ECDIS, because the ECDIS has a lot of rules that are kind of stringent in terms of just navigation. This is actually built with the same software an ECDIS is built with, but it's a planning station, so it opens it up to give us a lot more flexibility on what type of layers we can add, and basically complements what they're doing by giving them the ability to go in here and plan their voyage and then send their route to the ECDIS when they actually start to do the actual navigation. So there's a lot to go into, but I won't stop there with my sales pitch. But this is just this gives you at least a visual of what it looks like. So
looks really interesting. I guess it takes a little bit of education to really interpret all that data, but it's a lot of data, that's for sure.
Yeah, I would say that everyone on board has the education already to use the data, which is nice. It's just a matter of them getting comfortable with the platform. And actually the generation of people that haven't grown up with phones are the ones that really like this the most, because their complaint was, why are we going to have to use this tiny device to try to plan on when we had this giant chart table? And now we kind of have the best of both worlds. A big chart table gives you the updates that you couldn't get previously. So
fantastic. Excellent. Christoph, you have anything to add to that?
I guess the only thought is that I believe the need for a great integration of the various systems that you're using is getting higher the less bridge real estate you have to look at multiple things at the same time. So
Sure.
The less real estate you have, the more important it is that things are kind of developed in an integrated way. And that's, if I compare it to the automotive industry, it's typically the OEM who develops and defines the user interface for the people driving. And here it is often the people who contribute to the bridge electronics, like you have seen at NAVTOR, or like you've seen at what FarSounder has done. There's also some effort from some OEMs. So that's here it is a lot less clear how that integration is going to work. But we know that especially in environments where you have only little space to look at, it is important. Like this morning, I got a report from my car that I should change my tires because they are losing air. And so if I don't have that problem, it never shows up. But when it does need to show up, it does show up. And this kind of integration is, I believe, what we need for, in general, and especially for small bridge real estate situations.
Excellent.
I think there's also one additional component to integration, and that is integrating your own real measurements with historical measurements. Not, I talked already a lot about the real-time navigation, and Todd talked a lot about the planning portion of the navigation process. But all of these different sensors are doing things and sensing information along the way. It's nice if you don't have to throw it all out, so that you can use your own historical measurements as a planning aid when trying to figure out where you're going. And we do that with our local history map. Although we are focused primarily on a real-time capability, we have that map that I showed. And that works really nicely with the types of capabilities that Todd was talking about, because maybe you've been there before and you have some local knowledge that isn't available globally. And that local knowledge could be going into that lagoon. You got a little close to the reef on the way in, so you want to remember that on the way out, and give yourself a little bit more leeway as you're passing it, as one simple example. So integration, it's really a relative term that can be applied in a lot of different ways.
Excellent. That's a good example too. Perfect. So all of this brings me to something that is kind of near and dear to me. Has been when I was building large, dangerous pieces of yachting equipment. And now that I'm in the management business and working with crew, equally, if not more important, that is crew training. What's involved in getting people up to speed with and using this technology on the helm? You've got quite a number of potential crew that are going to touch this, not just the master of the vessel, but his first officer, possibly some junior deck officers might be in a situation, on watch, needing to have the ability to see, use, and manipulate the data that's being offered. Is there training programs? Are there requirements for training programs? How does that look? Kind of educate us, please.
I guess I'll chime in first here.
Todd?
Yeah, okay. So basically with our products, it's nice because, all the officers on board will already have training for navigation. And what we're doing really is letting them use their training most effectively. It's actually automating things, like, for instance, instead of having to, physically write out your passage plan and add total tide stations or all this different information, it can be compiled automatically in one place. Their chart gets updated, of course, automatically. So what we're doing is really automating things that used to be manual work that weren't really part of the job. It's just something they had to do because it wasn't a very efficient way to do things. And now
Sure.
they really can use their training in the most effective way. So that the idea is really to not have to do any of this manual stuff and really just get to the meat and potatoes of the navigation part, so that you can concentrate on the most important aspects of your voyage. So I guess the short answer is they already have the training. We're just giving them an easier way to do it. So.
Okay, excellent.
From the FarSounder point of view, as I mentioned before, we're not part of any required equipment. So our training doesn't fall under any SOLAS required training programs. That being said, though, there are a number of organizations that are providing training, required trainings, that are adding in sort of modules about these new products, technologies, and capabilities. And then there's also sort of industry-wide specific training options. Siebly is growing pretty well with a lot of product-specific training programs up there. The PYA is exploring new certifications for an official AVIT training program, and we've been discussing adding in how to use our equipment as part of that. And FarSounder, of course, we have our own online training that's open to all customers at no charge. From our website, it's just training.farsounder.com. And so we go through all the specifics to our thing. But fundamentally, we're focusing on piggybacking with the capabilities they're learning in the required training. So there's not really a lot to learn when they go to our product.
It's good to know. So we talked about transitioning from the whole idea of the training to what, I'm not sure if it was you, Todd, or you, Matt, that mentioned advanced assistance systems. Say that 3 times fast, please.
I think it was actually Christoph that brought that
Christoph, I'm sorry to bypass you there, Christoph. You're up. Talk to us about the advanced assistance systems.
Yeah, and tying into what we just discussed about trainings is in addition to training crew, another option that you have is training machines. So that machines can take over more competence to give better information on the bridge, and that's basically what we do at our company. So essentially, our solution is based on having gathered some 6 million marine objects that we feed into the artificial intelligence algorithm, if you will.
How many?
About 6 millions.
6 million.
6 millions, and so if you feed, so what you do in an AI approach, you don't define what is a sailing yacht, but instead you just, it's called annotation or labeling. You just feed pictures of sailing yachts, 1 mast, 2 masts, 3 masts, sails up, sails down from the side, from the bow, against the light, with the light, in various waters. So you just feed it into the system. You kind of label it as a sailing yacht, and then what's going to happen, the AI will self-select a couple 100,000 of filters, and by the kind of specific how the filters are matched, it will understand this is a sailing yacht, this is a motor yacht, this is a jet ski, this is a buoy or a fishing buoy, this is a swimmer in the water. And so some of these data for this training to develop smarter assistance systems, you just mount some of the systems on existing boats, and some of these you have to create yourself. So just to show how that works, I'm going to share a picture. For instance, in this case, as if you want to be able to detect floating containers, you cannot put cameras on a couple boats and hope you will see one, but you get a container, you throw it in the water, And then you see here is basically all our product range. So 3 product families that we've mounted. Of course, here we're already pretty close. And then you use that data from various objects, various angles, various waters. And then that will make the system smarter. And then the system can give better advice and better recommendation for crew.
Right. Ideal. Wow. Now, of course, that was a container you could actually see fairly well. My experience is some of those containers are very, very hidden by the ocean. Sometimes you only see a few centimeters above the water, but I assume the AI starts selecting that or understanding that.
Yes, and well, there's always, the AI will be capable of discriminating or distinguishing water from non-water. And if we are in the world where the camera systems detect something that is not water, if they realize what it is, you will get a symbol that the system has identified this is a jet ski. And if the AI sees that it's not water, but it cannot characterize what it is, you will get a warning that kind of say, I don't know what this is, but this is something you should
pay attention. Pay attention.
Yeah. And then you can select the object and take a closer look. Huh?
And it's sensitive enough you can actually see a person in the water.
Yes, I also have an image of that. Can share that. So wait a second. This is actually, I like to have a presentation of myself and presentations I give. So this is me off the coast of Mallorca. At about 1.5 meter wave height, seen through a thermal camera, i.e. works at day and at night. And so what you can see here is if you were on a search and rescue operation and you would look for the swimmer, you'd have a hard time.
Oh, yeah.
And especially if you don't do this only for 5 minutes, but if you need to do this for a couple hours, actually you can't beat the system at all. So that's kind of course, the system sees large container ships that you will also have on IRS and radar, but it will also capture smallish things. And that's important on the one hand for collision avoidance, because a collision with a jet ski or with a paddleboard is also not nice, even if it will not harm your ship, but still you want to avoid it. It can also be different situations, for instance, perimeter surveillance. If you are somewhere at anchor and you want to know whether somebody's approaching your yacht, you want to take a look before they're on the aft deck. Also, like in this case, search and rescue operations or object tracking.
Well, that's the first thing that came to mind, Christoph, is in my experiences, finding people in the water has been remarkably difficult. And, if you're in South Florida, you got some time. If they're in the water for a few hours, they might get a little cold, but you'll get them out of the water fine. But there's a lot of the ocean where you've got 8 minutes, maybe 5, 6, 7, 8 minutes before hypothermia basically ends that rescue and turns it into a recovery. So I could see that this is a technology that could truly be life-saving if it's utilized properly.
Absolutely. And there we are, I believe, back at the question of system integration and the power that a new generation of assistance systems can give to crews. That kind of opens the road also to the autonomous mobility discussion. There's a common misconception that people think a vehicle or a vessel is either fully manual, fully non-autonomous, and goes then to fully unmanned and fully autonomous. That's not the case. Yeah. It's happening, whether at sea, on the road, or in the air in the same way. You get ever more powerful assistance systems that give decision support to the crew. And then slowly you can give when you feel good enough about your assistance systems, you can give certain functions to the machine and take it away from the crew. And then the crew becomes more a watchdog of what the systems is doing, or in an extreme case, you indeed don't need it anymore. Wow. And the typical development is that different segments have different requirements. So some segments in the recreational sphere will go for more decision support. And then there are some segments, if we think about hydrographic survey, for instance, you go to fully autonomous. So Lloyd's Register separates 6 stages of autonomy by different levels of support from the machines. And different segments will have different needs and they will change over time. But it's clear that the direction of the change will not go towards more manual.
I'm sure that's true.
Yeah, we've been working involved in some defense projects where FarSounder is a underwater sensor for these fully autonomous platforms. And in many of those cases, they have a person on land or on the mothership who's giving the guidance as, we want you to get here, but we're not going to tell you how to do it. You, the vehicle, have to figure it out using your own sensors. And I don't think we're going to see that in yachting, but we are going to see a lot of those advances move into the yachting sector to make it easier to do more things with fewer people. So for yachting particularly, there's a huge pressure to get more of the guest-facing, the hotel staff on board to provide service to the guests. And all those pesky bridge crew get in the way by, taking up berths and food and space. And we keep asking the bridge crew to do more and more and more and more and more, but we're not expanding the bridge crew. So by bringing in these technologies we're developing for the fully autonomous systems into yachting, it frees up, time for the existing bridge crew to do more of those things.
That's cool. So gentlemen, we're coming to the end of our session here, and I thought I'd give each of you a couple minutes just to wrap things up and leave us with any thoughts that you would like to put out there to everybody who's tuned in today. Christoph, why don't you go first? Anything you want to say to bring us to a close?
Yeah, no, I guess the only thing I just wanted to share quickly how the system that I've described a lot, how it looks in real life. So I do this just for a brief couple of seconds. So this is how what our system would contribute to situational awareness. So you would detect various objects. You would also classify them, and then if there is a collision likely, you will get a warning, you will get a different color, and things that do not represent a collision risk will be highlighted differently. So this is kind of what we bring to the table and what needs to be integrated into more powerful systems like Matt was kind enough to already do fairly quickly, I must say, for a first draft. And I believe that's the way we're going to see the development here.
Well, I would sure like to see SEA.AI and some of the boats that we put together. I see some real benefits to your technology, and I give you a lot of credit for your forward thinking and the development that you're doing. Thank you.
Well, thank you, Rick.
Absolutely. What about you, Todd?
Well, I think I just want to kind of agree with what Matt said earlier about where basically the crews are getting smaller and smaller, but we're asking them to do more and more. We're seeing that a lot now because we're actually heavily involved in the performance part of reporting now. And there's a lot of regulations coming into force about reducing emissions and fuel consumption. And so there's been a lot more things asked of the crew to what they need to do. So whatever we can do in terms of automating is going to be a lot hugely helpful for them going down the road here, especially when there's more and more responsibilities that they're having to fulfill. So
fantastic. I appreciate the information that you've shared with us this morning. It's enlightening and to me fascinating. But again, I'm a bit of a neophyte in this, so maybe I'm easily impressed, but it is impressive. And Matthew, your thoughts?
Well, I think I'd just like to leave with the thought that a successful navigation is, in my opinion, part of a holistic approach. There are different sensors with different types of information that really are complementary, like the three companies we see here today. Rick, you mentioned the shipping container. Hey, a lot of the ones that I've seen are just barely sticking up out of the surface, and if there's waves, the camera might not pick them up.
Yep.
That's where the sonar comes in. The sonar sees that. So none of us believe that just a sonar or just a camera or just a chart solves every problem
Bring
all
it
the time.
together.
Exactly. So really what I'd like to see is let's start adopting these newer, and I say newer, FarSounder is 21 years old, but let's start adopting these newer technologies more widely across the industry, because it will reduce risk, whether that's monetary risk, environmental risk, health and safety risk. There's really no reason why we shouldn't be doing this nowadays.
Totally agree.
Amen.
Awesome. Well, listen, gentlemen, this has been really, really fun this morning. I appreciate the invitation to help moderate this and bring you guys, this talent, together. I'll put it out there that there's an interesting trade show in Amsterdam starting in a couple of weeks, the Mets. Anybody who's on the fence about going, I would suggest you do go. It's wide open this year, and there's some really fascinating technologies to be found there, as well as some of us will be there to meet and greet and answer questions and maybe have a beer. So thank you again. Thank you for joining us today, and look forward to the next opportunity to put another roundtable together.
Thanks, everybody.
Thank you.
Thanks,
Thank you,
Rick.
Rick.
Thanks, Christoph and Todd.
Thanks. Have a good day.
My pleasure, gentlemen.
See you at Mets.
All right. Be well.